Hi everybody, welcome to your second review lesson. This is like your practice test. So it's a little bit longer than the one that we did first. That was kind of like a cheat sheet. But still shouldn't be too bad. So our first question, write each expression as a single power. You do not need to evaluate. I'm assuming everyone knows how to use their calculator, or you've asked me by now how to use your calculator. So we're just going to go over the laws. Now, if you're not sure, a dot means multiply. And when we multiply like bases, so remember you can only use the rules when the base is the same, which it is. You rewrite the base, which is 3, and you add the exponents. So what's 3 plus negative 4? That's negative 1. And then we have to use our negative exponent law, which says, remember, two parts, flip it. Now how do you flip a whole number? You have to remember that it's really written over 1. So we can kind of do that small if you want. So flip it, 1/3, and make the exponent positive, which is 1. B, power of a power law. Rewrite the base, which is 4, and we multiply the exponents. 4 times 5, 20. C, this is quotient law. We are dividing, and when we divide, we subtract the exponents. So the base is the same, so we rewrite the base and subtract. Now you might want to use your calculator, no guessing, because, as an aside here, negative 2 minus negative 6, remember two negatives make a positive, so really this turns into positive 4. Number 2, evaluate each expression as a fraction or integer. No decimals. Okay. So in order to do this, you're going to have to use your exponent laws and then use your calculator, or knowledge of your calculator. So for A, we have a negative exponent. What do we have to do? Flip it, which that's going to be 1 over negative 4, and then make the exponent positive. And then that exponent goes to everything inside the brackets, don't forget. So 1 cubed, and then negative 4 cubed. 1 cubed is 1 if you use your calculator. And then negative 4 in brackets, cubed, is negative 64. There's our final answer with no decimals. B, negative exponent, flip it. So that becomes 4 over negative 3. Make the exponent positive. That exponent goes to everything inside the brackets. So 4 cubed, negative 3 cubed. Using your calculator, 4 cubed is 64. Negative 3 in brackets cubed is negative 27. And there's our final answer. Again, no decimals. This is showing that you know how to use the laws. C, power law to start, right? We see back-to-back exponents here, and we see here. So we multiply. What's 2 times 0? 0. So we get 6 to the 0 plus 2 times 0 again. 0, 6 to the 0. Everyone should remember what's anything to the power of 0. 1 plus 1 equals 2. Number 3, true-false. Doubling time is the time needed for a radioactive sample to decay by half. False. Doubling time is how long it takes to double. B, any base raised to a negative exponent is equal to the reciprocal raised to the same positive exponent. Now, if you don't know what the word reciprocal means, it just means flip. And as soon as you see that, that's true. We flip it and we make the exponent positive. Any number to the exponent of 0 is equal to 0. That's false. We know that's 1. In the relation P equals IB to the T, if B is between 0 and 1, it represents exponential decay. That is true. If it's between 0 and 1, remember that's a positive fraction or positive decimal. And if that's the case, it's decay. The base of any exponential half-life is always 0.5. True. Half-life, 0.5. Number 4, calculate the growth rate of a population which increases by 7.5%. This just comes down to you realizing you got to make these decimals first, which means you divide by 100. So you get that. And remember we do 1 plus r, that's our growth rate. 1 plus 0.075, which equals 1.075. Calculate the decay rate. Exact same process, divide by 100. We don't know what that is, we just did it. But instead, for decay, it's 1 minus. So 1 minus 0.075. And if we use our calculator, we should get 0.925. Number 6, determine if it's exponential without graphing. I've even given you a huge hint here. I've told you to do ratios and do y2 divided by y1, which means start at the bottom, draw this little staircase accordion shape, and we don't subtract, we divide if we want to determine if something is exponential. So using your calculator, start at the bottom, work your way up, divide those two numbers. We'll say round to 2 decimal places if necessary. That you should get 2.44. That you should get 3.16. The next one you should get 5.06, and then 16 divided by 1 is 16. Are those all the same number? No. Is it exponential then? No. And make sure you know the why. Why is it not exponential? Because ratios were not equal. If all of those numbers were the same, then we would say yes, it is exponential. Why? Ratios are equal or were equal. Number 7. We're going to look at the following 4 graphs, and we want to match each graph to each equation on the left. And then B, which graphs show decay, which graphs show growth. I'm going to start with B and C actually. They're easier. So we'll start with the decay or growth. If we look over at our graphs, if we look at A, the red line, as we go left to right, so as you trace along, go left to right with your finger, we are decreasing. If we are decreasing as we go left to right, it is decay. So we already know for sure A is decay. Let's go to B, the green line. Trace along with your finger. As I go left to right, my green line is decreasing. So A and B show decay. C and D, so let's start with C, the purple one. As you go left to right, your graph is increasing, it's getting higher. We know that's growth. And if we look at the blue line, as I go left to right, trace along with your finger, it's increasing. That's also growth. Now, matching the graphs to the equations. The first thing I would say to you is, remember, if your base is a whole number bigger than 1, those are growth. So if you look at those 4 equations, there's only 2 that we know are growth. That one and that one. Why are those 2 growth? Because the base is bigger than 1. So I'm just going to put a little g there for growth. So we know we're picking from C or D. Now, if you remember from one of our lessons on exponential relations, some of the patterns, the steeper the graph, the bigger the base. So if you're looking at C and D, which graph looks steeper?
Here's what I found on the web.
So if you look at C and D, which graph looks steeper or increases faster? Hopefully you're thinking C, so C is steeper. The bigger the base, the steeper it is. The bigger the number of the bases, the steeper it is. So C, which is the purple one, goes with 5 to the x because 5 is a bigger base than 2. And that means D goes there. Decay, remember our fractions are decimals between 0 and 1. So I see 1/5 and 1/2. So those are definitely decay. So we're picking from A and B. And if you remember back to that lesson that I just referred to, for decay, it works opposite. The lower the base, the steeper the graph, meaning the lower the number, or the number that's closest to 0. So if you're looking at A and B, which graph falls steeper or falls quicker? Hopefully you're thinking B. B is steeper. It falls a lot quicker over time. And which number or base is smallest out of 1/5 and 1/2? And if fractions aren't your thing, convert them to decimals. So let's just say you want to convert that to a decimal. That you would get 0.2. That you would get 0.5. Most of us should be able to compare those. Which one is smaller? Hopefully you're saying 0.2, which goes with 1/5. And again, the smaller the base, the steeper it is for decay. So that means that is B, and that is A. Our next question. Number 8. The growth of a bacterial culture can be modeled using this formula, where n is the number of bacteria after t hours. What is the initial population? So this is just you understanding how the equations are modeled or how they're put together. So initial means starting population. And if we look at if we go back to our equations lessons, or modeling equations, sorry, this number right here is always the starting value. So what is the initial population? 1,500. How long does it take for the bacteria to double? Well, we know it's double because there's a 2 there, that's the base. And again, this goes back to your understanding of the equations for doubling time. So remember, your equation for doubling time is normally A equals P, 2, and then T over D. And that D value on the bottom of the fraction is your doubling time. So again, we don't have to do any work, we just have to go back to understanding these equations. That right there is where the D normally is. So how long does it take for the bacteria to double? 3 hours. That's just pulling the information right out of our equation. How many bacteria are present after 8 hours? So now we're going to actually use the equation. And we're going to put 8 in for T. So 8 over 3. Again, make sure that you do as I've been stressing over the past couple lessons, do the exponent calculation first. And if there's decimals, maybe round to like 3 decimal places or something like that. So make sure you do 8 divided by 3 first, then write that number down, and then do 1,500 bracket 2 bracket to that decimal. So make sure you know how to do that. And then if you've done it correctly, you should get 9,524 bacteria. And again, do not forget for a word problem to do your therefore statements. Number 9, the half-life of sodium bicarbonate is 50 days. Find the amount of sodium bicarbonate that is left 200 days if you started with 80 grams. So this is half-life. So A equals the starting amount, 80 grams. Since it says half-life, 0.5. And then it would be T over H. The time is 200 days over H. It tells you the half-life is 50 days. Make sure you do the exponent calculation first. So this equals 80, 0.5, and then 200 divided by 50. You should be getting 4. And then enter that in your calculator just like you see it. And you should get 5 grams. And then don't forget therefore statement. Number 10, from 1999 to 2009, the average personal income grew in Canada according to this relation. If seeing those letters rattle you, you can always just change them to what we did. A and P, they're the exact same thing. And A is the resulting income, and P is the initial income, and N is the number of years. So according to the relation, what is the annual increase percentage? So what you have to know, first of all, you know it's increasing because the base is bigger than 1. We got 1.041. And then you got to realize that I've got to think about this. If it's increasing, normally it's 1 plus R. So I got 1.041. So that must mean R has got to equal 0.041 because 1 plus that gives you 1.041. But we want it as a percentage. So we're going to work backwards here. Times it by 100%, which will give you 4.1%. Hopefully that makes sense to everybody. That's kind of working backwards to how we worked coming up with the equation. So really test your understanding of that. B, if a person's income was $35,099, what would it be in 2009? So A equals our starting amount, 35,000, 1.041. And remember, common mistake, someone's going to put 2009 in for the exponent. You are going to get an astronomical number, like number so high that it should ring alarm bells that someone's income went from 35,000 to like hundreds of millions in 10 years. So I just gave you away the answer to what the exponent should be. If it's 99 to 2009, how many years is that? That's 10. That becomes our exponent. So that's 10 years. That's just calculator work. For money, even if I don't tell you how many decimal places to go to, you should go to 2 decimal places. You should hopefully get $52,308.87. Again, just to keep stressing that, therefore statement. Assuming that that's still currently used to model the growth of Canadian income, how much could a person expect to earn this year? So we're going to assume the same parameters. Person starts with 35,000, 1.041. But then you got to figure out this year. This year is 2021. So we got to do 2021 minus 1999. So when you do 2021 minus 1999, you should get 22 years. So that means we have an exponent of 22. Enter that in your calculator just like you see it, 35,000, bracket 1.041, close bracket, exponent 22. 2 decimal places for money. I get $84,719. And remember our rounding rules, 64 cents. And then don't forget your therefore statement. Hopefully that makes sense to everybody. Again, remember if it doesn't, make sure you ask me as many questions before your test. Our next question, explain how you can determine if a relation is exponential given each one of these things. So explanation could be point form, could be full sentences, could involve a picture or a diagram from a table of values. You know that it is exponential if the ratios are equal. So what I'm going to write here is divide the y values from bottom to top if the ratios are equal. It's exponential. Something like that would be perfect. Full marks. From the equation, so if you're looking at an equation, we have something like this, a equals b to the x. So equation looks like that, and the key is the variable, which in this case is x, is the exponent. All you have to say. From a graph, this is one that we could use a picture for. For a graph, it could be something that looks like that, which we know is growth, or it could be something that looks like that, which we know is decay. And that's all you have to say. So again, to summarize, table of values, ratios are equal, equation, the variable is the exponent, graph, it has to look like one of those two graphs. One's growth, one is decay. Our next question is a bit of a thinking question. So Vanessa's helping her friend Sasha study for a quiz. They're working on simplifying the expression 2 to the negative 2 times 2, and Vanessa notices errors in Sasha's solution. Explain where she went wrong and correct her solution. For some people, doing the correct solution is probably going to be a good starting point. So do the correct solution first and then establish where she went wrong, assuming you know what you're doing. So let's start over here, and this is the correct solution, as if I gave it to you on a test. So if we have 2 to the negative 2 times 2. So first thing, bases are the same, so you rewrite the base, and when you multiply, you add the exponents. Now that second 2 doesn't look like it has an exponent on it. Don't put 0 there. And you know you shouldn't put 0 there because 2 to the 0 is 1, so it would be times 1, not times 2. So you have to remember what's really there, but we don't write it because it's redundant to write it, is really there's a 1 there. Add your exponents. Negative 2 plus 1 gives you negative 1. And we know what to do with a negative exponent. We flip it. If it's a whole number, it's really written over 1. So when you flip it, 1/2, make the exponent positive. And then put that exponent to everything in the bracket. So 1 to the 1 over 2 to the 1, which 1 to the 1's 1, 2 to the 1's 2. So there's our correct solution. Let's figure out now where Sasha went wrong. So here's our first step right here. Here's her first step. So what did she do? She added, so she added the exponents correctly, but she got 4 there. So her first mistake was she multiplied the bases, which we know you don't do. Okay, next step. So she realized she had a negative exponent, so she flipped it. That was good. She made her exponent positive. That was good, but she threw out this negative out front. So no negative out front. And then her solution based off of her wrong work was correct. So she made 2 mistakes, multiplied the bases, and then she put a negative out front. And we have our correct solution to back that up. And our last question of the review, a rare coin is purchased for $2,500 in 1990. It appreciates by value, 7% each year. Write a formula that models the situation. So you have to know what the word appreciates means. And if you don't, I'm going to tell you, appreciates just means it increases in value. If you saw a question that said the opposite of appreciates, so it says depreciates, that would mean it decreases in value. So write a formula. A equals our starting amount, 2,500. And if it's appreciating, it's increasing, so we know it's plus. Don't write 7 here. Remember, you got to convert that to a decimal first, so divide by 100, 0.07, and then to the exponent t for time. How much is the coin worth in 2012? So A equals 2,500, 1 plus 0.07. Do not put 2012 in there. You're going to get a huge number. It starts in 1990. So to get your exponent, 2012 minus 1990, you should get 22. Then you enter that, so 22 years, then enter that in your calculator just like you see it. Go to 2 decimal places if necessary. I don't think it's necessary in this instance. Let's just double check, 2,500. And brackets 1 plus 0.07, close bracket exponent 22. Yeah, so you end up with double zeros on the end. So we get $11,076. And don't forget for a word problem, a therefore statement. So that's it for your second part of your review, our practice test. Now you can work on your workbook questions or anything else you haven't finished. Remember, there's no assignment for this unit, just the test coming up potentially later this afternoon if you're doing this in the morning. And remember, again, just another friendly reminder, if you can figure out how to get all of your pictures into one PDF or document or some other way where it's just one file, and instead of emailing it to me or sending it to me in Hasia, you are able to put it in the appropriate Dropbox under assignments and exponential test, I will give you 2 bonus marks on your test right off the top. You'll get 2 bonus marks. And again, just another gentle reminder for your test, you selecting the right multiple choice answer is the least of your worries. I care more about the process, especially since, it's could be a collaborative exercise if you're helping each other and it's open book right in front of you, plus you have lots of time. I need to know that you know what you're doing. You're not just looking it up online or somewhere else. I need to see the process. So show me as much work as you possibly can for each question. Even if you think it's like a 1-line question, write me a little point form note on how you know how that's the answer. And again, for some of you, you're a little bit disorganized in your uploads and in your work, where you don't go 1, 2, 3, 4, 5, 6 in chronological order. You go like 1, then you skip to 8, then you forget to write down what the question number is. And again, I'll do my best to figure out what you're doing. It just really slows the process down for me for marking and then getting you feedback and your marks back. So especially this week where we don't have a lot of turnover time, we have our 5 days together, then you got the weekend, and then you go right to your CCA. You being able to do those, you're going to get 2 bonus marks, but you're also going to ensure that I can mark the things and get them back to you quicker. Hopefully, before your CCA, if I have time over the weekend or not. But yeah, like I said, you guys are working hard. Try your best. Make sure you upload as much work as you can. Ask as many questions as you need to. There's only a couple units left, plus your CCA. And I want you guys to be as successful as you possibly can. So good luck on your test later this afternoon. And we'll be in touch tomorrow for starting your final unit, which is finance.